So we've done algebraic proofs, and now we're moving on to geometric proofs. And so geometry deals with numbers as measures. So geometric proofs use properties of numbers, and here's some algebraic properties that are used in proofs. It's the reflexive property, which states that AB is equal to AB, right? So the measure of line segment AB is equal to the measure of line segment AB. And we also can apply that towards angles. So we have the measure of angle 1 is equal to the measure of angle 2. We also have the symmetric property. If the measure of AB is equal to the measure of CD, then we could flip that around and we could say the measure of CD is equal to the measure of AB. We could also do that with the measures of angles as well. And then lastly, we can apply the transitive property. So if the measure of AB is equal to CD, the measure of CD, and the measure of CD is equal to the measure of EF, then we could say that AB, the measure of AB, is equal to the measure of EF, like so. And we could do the same with angle measurements, right? And so just one thing to note is that when we don't have the line over the 2 points, it's read measure of AB. So let's say AB is read the measure of line segment AB. All right. And AB without the line over it is a number. Right? So AB could be 5, AB could be 6, it could be 7. AB is the measure of this line segment AB. If you have the line over it, then this line segment AB refers to the figure, right? Refers to the line segment. But AB without the line over it refers to the measure of the line segment. So this here is a number. Okay, it's a number, which is why we're able to use the algebraic properties reflexive, symmetric, and transitive, because AB is a number. Same thing with measure with that little m. So I'm going to write it down here. The little m, measure angle 1, is read the measure of angle 1. The measure of angle 1. So m angle 1 is a number. It's the number of degrees in the angle, which is why if we use the measure of angle 1 and not just angle 1, we're able to use the algebraic properties, right? Angle 1 without the little without the little m refers to the angle in the figure, right? Measure angle 1 refers to the number of degrees. So measure angle 1 is a number. Measure angle 2 is a number, right? Which is why we're able to apply these properties. Let's go ahead and write our first geometric proof. We're given that m1 is equal to m2, and we're also given m2 is equal to m3. So angle m1 right here, so m1 is congruent with m2, with angle 2, and then the measure of angle 2 is congruent with the measure of angle 3, so we do that. So this angle is congruent with that angle, is congruent with that angle, which means they're so if this is 130 degrees or 110 degrees, then angle 2 is 110 degrees, which means angle 3 is also 110 degrees. Right? But we need to prove this using our properties. So we start with our given, right? M1 is equal to M2. That is a given, so my reason is going to be given. My M2 is equal to M3, which is also a given, so I'm going to go ahead and write given here as well. And then lastly, we have measure angle 1 is equal to measure angle 2. Now, how can we prove that? Well, we have our transitive property, right? If measure angle 1 is equal to measure angle 2, and measure angle 2 is equal to measure angle 3, then we could say that measure angle 1 is equal to measure angle 3. Like so. Okay, so the reason that we're able to say this is our transitive property. Like so. And we're done.